Hello and welcome everyone to another session in the Data series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Shishir, part of the data science team at Analytics Vidhya, and I will be the moderator for this session. For those who have joined us for the first time, a brief introduction about the DataHour sessions. The DataHour is a series of webinars conducted by Analytics Vidhya led by top industries experts. It's a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now on to a session today, which is Introduction to MLOps. This data hour will help introduce you to the hottest topic in the industry, that is MLOps. Whether you are a data science enthusiast or a working professional, it is essential to know the future of data science. Now, on to our speaker. In this session of Data Hour, we have with us Anish Mahapatra from Bangalore, India. One of the youngest data scientists in India, Anish has been a lead data science consultant for multiple Fortune 500 clients and has helped over 22,000 people enter the field of data science. He has a dual master's in data science and is a technical writer for many top science publications. He is always happy to help people. The best introduction for Anish Mahapatra will be to simply Google him. You can get to know more about him through his website www.anishmahapatra.com. Well, that being said, Anish, the virtual stage is all yours.
Thank you, Shishir. All right. Hello, good morning, good evening, good afternoon, wherever you are from the world. Thank you very much for joining me today for 1 hour. So I'll just go ahead and share my screen. Please let me know if you're able to see it. All right. Okay. So, Shishir, I'll go ahead and start. Anything else?
Yes, Anish, you can start. Nothing.
All right. So just a quick note from my end. While presenting, I will not be able to see the chats or if you raise your hand. In case my audio goes off or there's any issue, Shishir will take over. If you have any questions through the session, please feel free to put your question and answers in the Q&A section specifically so that we'll be able to answer them towards the end. All right. Having said that, welcome everyone. Thank you so much for joining me today and giving me 1 hour of your time, where I'm going to focus on the introduction to MLOps. Right? MLOps has been a very hot topic in the industry of late, and the number of jobs for MLOps now and in the future is only going to rise, at least for the next half decade. Having said that, let's just go over to the agenda so we know what we're working with. All right. So today we'll just do a quick introduction of me. Shishi, thank you for the nice introduction. We'll focus on what is the current and future state of ML, which is machine learning. What does technical debt in machine learning systems mean? In the sense that we are in the process of iterating and building models so fast, right? So what is the other side? What does the other side of it look like? Next thing we'll focus on what does the new world machine learning look like, or how do we move our projects that we are constantly doing as prototypes on Kaggle, on Jupyter Notebooks, how do we productionize them? How are companies making money off of machine learning, and what does the future look like? To enable this, what are the tools and technologies that we need to be able to perform MLOps? And finally, we'll go ahead and have the Q&A session. All right. So introduction, first thing, am I worth your time? All right, so I am Anish Mahapatra. I am a lead data scientist, and I currently work for a Fortune 200 retail giant. If you have any questions throughout the sessions later on, you want to reach out, please feel free to Google my name. I think that's the easiest way to find me, or you can send me an email, right? So these are my social media handles in case you want to connect further. These are some of the brands I've been associated with. I've been college, my master's degree, and so on and so forth. And I've also worked with Mu Sigma. The next thing is like, how do you know what the future of data science is? Simple, like just ask a real world data scientist, right? Like all of us have gathered here to understand what the future looks like. This, you can say, is my opinion, but it is a general industry accepted answer that MLOps is the future of data science, right? So before we delve off into the future, Let's try to understand what is the current state of ML. Where are we right now, right? If you were to look at a report by VentureBeat and Gartner a couple of years ago, it said that 87% of data science projects do not make it to production. This essentially means that we are iterating and building experiments really well, but we're not able to make money off of it, or we're not able to productionize it. So it's a question of understanding why, right? So I think one good way is, we'll just take a quick example, right? Let's say we're trying to build a warehouse optimization tool, right? Some of you are experienced, some of you are fresh. So I'll just give you what are the perceived roles in the industry right now. We have multiple warehouses through Chennai, Mumbai, Bangalore. We're going to get all that data onto one place. We're going to clean and sanitize it. Here we're going to have our data in different formats like Excel, database. We're going to have it on some cloud platform, and we're going to build one master data set, right? Once you have this master data set, let's say we want to analyze what are our best products and what are our worst products, right? One way that we can go about it is, we can ask and understand what is the current business process to identify best and worst products. Let's say there were 30 umbrellas for the past quarter and no one has bought umbrellas, and that would be a bad model, right? So that would be a bad product. So here, this business rule is essentially called a heuristical model. Let's say we look at the sale of firecrackers throughout 5 years, or we look at it in a particular year. In a particular year, it might be less during a certain period. Whereas if you look at, let's say, the July 4th weekend coming up, or Diwali in India, we'll be able to identify that there is a seasonality, right? This can be identified through a statistical model. And the same thing, where the input is all of our products from all these different places, and the output is the top 10 and let's say bottom 10 worst products. You can think of ML as a black box that's able to achieve the same thing. And this is finally taken to a business. We can't just send them an Excel file and say, hey, here are the top 10, here are the bottom 10. To this, we want to give them more flexibility. Okay, for this particular location, for last quarter, in this particular category, what were my good products and bad products, right? This can be done with the help of visualizations, right? Currently in the industry, more or less, so data science is in a nascent stage. It has evolved a lot over the past couple of years specifically. But these are the roles that are perceived in the industry, which is you're going to have a data engineer to be able to move data from point A to point B, which is similar to a water pipeline. You're going to have data pipelines. Then you have a machine learning engineer that's focused on sort of the implementation part of it, where you combine data science and engineering principles to be able to move things along. And a business analyst that's in charge of querying, in charge of dealing with stakeholders, the business, and getting value out of the product, right? And the end-to-end right now is perceived as data scientist. And in each company, this role is going to differ. So the best way to understand what exactly the role pertains is to talk to somebody who's doing it. It's not standardized, right? So if you were to look at how in the future, or how currently the pipeline is set up so that the roles can be accommodated in the future, first thing we would have is a data engineer. Data engineers are needed. The second process, which is a data scientist, is responsible to do the experimentation, the feature engineering, make a prototype model and try to scale it up, right? To implement and productionalize this, which is how are we going to get to the end of it? Are we going to serve it as a pickle file? Are we going to serve it as a web application? Are we going to try and build some sort of containerization which can be moved and used by different APIs? So that part is done by a machine learning engineer. And finally, we're going to focus on how we can present it, right? So that's going to be done by a business analyst. So end to end, this makes sense at the moment, but where are we headed towards, right? So I think a good way to understand is by looking a little bit more into the current state of ML. But before that, a quick statistic from LinkedIn, right? The number of data scientist jobs have sort of peaked, if you in the sense that data science exists as a field, but people are looking for something a little more specific, whether it's cloud platforms like GCP, Azure, AWS, or whether it's roles like machine learning engineer, where you're not just coming out and learning a few concepts and making a model and moving on. People are trying to know, how do we actually engineer and implement it? So what are the tools and technologies, or how can we actually make money off the models, right? So in terms of the current state of ML, right? So if you were to look at how do we do data science now as data scientists, this is an image that comes to mind, right? So this is from a paper by Google Cloud. So within this, we go through our data extraction and analysis. We prepare our data, we do model training, we do model evaluation, validation, we train our model. This is something this and till here, a lot of us have gotten to, right? We have a trained model, we're able to test it on the one piece of data that has come. If I was to give you streaming data or a continuous set of data, do you know what that side of things looks like? Like that's the operationalization side of things. When we say MLOps, we're focusing on machine learning operationalization. So all of these trained models, where we move past the experimentation and development and testing stage to actually operationalizing it, is the ops stage. We then move on to something called a model registry. Let's say we made one version of the model and we have 5 team members working on different aggregations of data or different kinds of models or 5 different approaches. How are we going to share that knowledge? Okay, fine. You're sitting across a room, you attend Scrum and you share that knowledge. But from there, let's say we scale up to 50, right? Data science seems to be a very manual knowledge sharing sort of process, and we're not able to bring structure on how to scale data science and implement things. But it is being done, and like it is coming up, but we're not able to generalize it because everybody has a different technology stack. Everybody might be using different sort of tools and like different ways of going about to solve a data science problem. So how do we standardize it, right? Data science follows something called the case principle, which is change anything and it changes everything. If I remove a feature, if I aggregate a feature, if I add any sort of new variables, or there's a bias in the data, it severely affects what the rest of my models look like, right? So from here we'll also go ahead and analyze how we can overcome this and what the future looks like, right? So I think we've understood what a model registry is, where we have different versions of models. So if you want, after 5 iterations, we can come back to the first iteration and see, okay, what had we done then? Did that model perform better? Has the data changed? What does my model in the real world look like now? And from there, we go on to model serving, which is as a web service or as some sort of application that can be used. And finally, you get your prediction, right? An example would be Google Maps. Google Maps must have millions of models playing out in the backend, where when we hit like where we want to go and where we're coming from, they're going to go ahead and predict that. So that is a prediction service that can be from the cloud, or it can even be deployed on your local device. That's called TensorFlow Lite, right? From here, let's focus a little bit on what is the current state of ML. I think this is a very real tweet that I read, which is the story of enterprise machine learning is that it took me 3 weeks to develop the model, but it's been greater than 11 months and it's still not deployed. So how do we enable different folks to be able to move to deploy models faster, right? What do we need to do to, like give power to teams to be able to deploy models faster? So if you look at the current state of enterprise model, like just a different definition, because all of us have worked maybe on a Kaggle project, maybe on our own personal projects, right? From there, how do companies really work? For those data scientists out there, I'm sure this is a good representation where it's a little bit of everything and it's a little bit of everything all the time till something feels right or strikes right, or there is validation from the business team. Right? This does not start anywhere. I mean, like it starts from business understanding, where you have your product owners, they're able to understand what does it currently look like, what are the problems I'm trying to solve. From there, you're going to go on to data acquisition and understanding. We're trying to understand, okay, where are my data sources? Because generally data sources have multiple owners. So are you able to get a single POC, person of connect, to be able to source all of those permissions, right? From there, you're going to start building pipelines. Who's going to monitor them? How are we going to automate them? How are we going to orchestrate them? Right? Because now let's say we found a way to pull from a SQL database. How do I know that every day at 5 p.m. I want this data pulled? If it's pulled, send me an email that says good. If not, say that there was an error and I need to go and see what's happening, right? At different environments, people use Azure, GCP, AWS, wrangling, right? From there, we move on to the modeling stage, where we do feature engineering, model training, model evaluation. So through and through, you'll notice these arrows are double-sided. The reason is once you go to modeling stage, you might realize that you want some more data. You might come back here. From there, your business understanding might need to be validated. Maybe the business wants something and we don't have the data for it. So how are we going to find a good balance to be able to get to a point where we are able to deliver value from the data, right? Ultimately, if you look at the industry as a whole, right, whether we're comparing web developers, sales, HR, right? So people who enter the industry now are trying to fit in with the existing ecosystem and either trying to maintain it or make iterations to make it better. Whereas data as a field is going to grow for the next decade because all companies are building it, right? Currently, we are still in the data acquisition and understanding phase, because I've worked with multiple Fortune 500 companies who want to do data science, who want to do data analytics, right? But they have their data stored across 70 different countries in 500 plus different data silos. How are we going to bring everything together? We're on that stage. But it's also time to be thinking about how we're also going to leverage that data. There are a few companies that are doing it well, Apple and Google namely, right? But we aren't able to understand how they will do so well because they follow MLOps practices very stringently, because they have been doing this R&D paper, this research and development since 2004. That is why they are ahead of the industry, right? We'll also discuss one of the papers in the upcoming slides. All right. So what does the future state of ML look like? Maybe folks here are data scientists or aspiring data scientists or data engineers or data analysts, right? So what are the roles that are coming up in the future? All right. So we have our business owners, we have our subject matter experts. From there, this is the part that we are aware of, right? We have data engineers, we have who get us the data and are able to build pipelines to be able to monitor it effectively. We have a data scientist who play around with the data and build a model. We get validation from the subject matter expert, and then we call it done. Very, very few people, maybe less than 10% of people I've met have actually deployed a model, seen it run in the real world, felt the issues, because 87% of machine learning models don't make it to production, right? But in the future, now that we're overcoming that stage, we're also going to have a DevOps role, a data engineer DevOps, a data engineer, software engineer, ML architect. Now you're like, Anish, what are these new words? All right. So if you look at DevOps, right? So software engineering as a product was used to follow a waterfall model where we're trying to focus on, okay, there are requirements. If you go through 1, 2, 3 stages, 1 through 10, we're going to get the final output. But right now, let's say Flipkart, for instance, if they want to try a new banner or they want to try to change the placement of the shop button, right? They're going to do something called A/B testing, which is they're going to try out the change on a small sample size, see if it is effective there, justify that hypothesis, and then scale it up to a larger design, right? Now, but we cannot obviously pause the website while we're trying to do this change. So any change that's made, there are automated pipelines in the background that are going to ensure that the website does not go down. This is something called CI/CD, right? It's continuous integration and continuous deployment, right? So for that, we have something called DevOps. So what is MLOps per se? We'll delve a little bit deeper into that question, but this should let you know what are the jobs that are going to come up with relevance to MLOps. This is again sourced from O'Reilly. So there's a great book on the introduction to MLOps, right? So one thing to be very clear, right? Everything I'm saying today is the initial stages. Right now, it is still in the process of being researched. The latest 2000 articles on MLOps must have been written in the past 4 to 5 months, right? It's that new that you won't find that many things, right? So what is the future state of enterprise machine learning look like? This is the path that we knew, where we go from our data analysis, we orchestrate our experimentation stages, we go through our model analysis, and we finally have a source repository. Like we saw before, this is the experimentation, development, and testing stage, right? Post this is when the operationalization starts, right? Operationalization is staging, pre-production, and production. For some of you that might have worked in a software development environment, we have a dev environment, we have a QA, and then we have production, right? So similarly, we have pre-production, then production, which is same as QA, right? So once we deploy those pipelines, now what is a pipeline? Like all these new words you're throwing at me. Okay. So water helps, like a normal pipeline helps water go from point A to point B. That's a water pipeline, right? Where we set the process and the flow of things happen in accordance. And if there's a break, we'll know. Similarly, a data pipeline helps carry data from point A to point B. In between, you might want to clean it, standardize it, or make any sort of change and check if the data is there or not, if it follows the processes, and then the data is supposed to come out. So similarly, for machine learning models also, it is possible to build pipelines. For instance, we do feature engineering, right? and we might choose lasso or ridge regression to choose the top 10 features, or random forest, or XGBoost, or cat boost. But why only those? How do we know those are right? Rather, the idea should be to build a generalized pipeline that's going to try all of these models. And the job of a data scientist is to select which ones out of these should we interpret and which one can add value to the business, right? The idea of automating things is going to make things more lean, efficient, and is going to help us go back and identify and generalize things, right? So from here, we can go to the feature store, which is how we're going to store the features. Now, if you have 500 people working on one large data set with a billion rows, right? I understand that some of you might have questions. We'll probably take them towards the end. Oh, all right. The question on the terminology on the particular slide. Shishi, do you want to elaborate?
Yeah, so there's a question on what is model registry. One of the users wanted to ask.
Oh, all right, Jatin. Yeah, so a model registry is when we have, let's say, 20 different models. Let's say we have a data set at a 5-minute level, and we're going to make a few models, on that data set. But then they realize, okay, let's aggregate it and also make a different set of models at 1 hour level or 6 hour level. Now, let's say we also want to try 5 different models. So how are we going to track all of this? This can be done through something called a model registry, which is going to tell you what was your source data set, what was the model that you tried, what were the output metrics, and which version of trial is this. And if you update something, it's basically a lineage of your model history, right? Okay, so that is stored in an automated way. That's called a model registry. Similarly, you have feature store, right? We do feature engineering in data science, where let's say we have how big a house is, how much a house costs, right? These would be 2 features. A new feature would be total area divided by price. They'll give you price per square inch or whatever you're looking at, right? So that would be a new feature. So similarly, to build models for different data sets, we're going to build a lot of features, and some different teams might have different ideas of how to go about it. A good way to track that is through a feature store. Right. So from there, we're going to again go into an automated pipeline. See, these are orchestrated experiments and these are automated pipelines. And again, this is on Google Cloud, but the logic applies across any cloud platform or any MLOps platform, right? So from here, I'm going to need a trigger. Okay, so I've built a model. I know that I need to get the output of the model every day or every week or once every 2 weeks or whatever the trigger is, right? So I'm going to say, okay, once it is 5 p.m. on Saturday, I want you to run this model and tell me what the output looks like. So when I say trigger this model, I want this entire pipeline, which I have tried here as an experiment, to run automatically, right? So what will this pipeline have? It's going to have one orchestration, which is it's called a makefile, right? So a makefile is going to have, okay, spin up a dynamic cluster of this particular configuration. We have a requirements.txt file. I understand some of you might not be following me right now, but essentially what I'm saying is we have somebody to drive the show who's going to tell, okay, do this, which is install the different requirements that we have to run that experiment, spin up the cluster, run. Before you run, make sure you do checks on the quality of the data and the code, right? So what are the unit tests that you're going to do? For instance, with code, if you're doing Python code, we can look at PEP8. If you're looking at folder structure, there's something called cookie cutter, right? Whatever the global standards are that we want to follow, we can automate them in this pipeline so we don't have to check manually every time. So the output, once we get it, will be an automated report. If the pipeline runs successfully, let's tell the stakeholder, okay, the machine learning model is updated off of this date. And in case it fails, then we send an automated mail to the developer saying, hey, can you go and check the machine learning model once it seems like the data didn't land, or any sort of errors that we have, right? So all of this would come under metadata, which is information about the model, which is not explicit data, but it's implicit information, which is called a metadata store, right? So from here, we're going to come back. We're going to do our model serving. And from there, we're going to have our predictions. Now, from these predictions, we also want to be able to track, okay, what does the performance monitoring look like? Has the model drifted? Let's say 6 months ago, we made a model, then pandemic came. The model has changed now, right? So are we tracking that? Are we able to identify that people are not satisfied or the model is not performing as required, right? All right. So with this is the next topic, which is the hidden technical debt in ML systems. This is something that applies to all technical fields. So in office, let's say we have, or what else our projects are doing, you want to take 2 months to be able to do it perfectly, right? But we have clients, we have requirements, business needs results. We aren't able to do it in 2 months. So you're going to do something in 2 weeks, as fast as possible. Does that mean that you have taken the effort from 2 months and jam packed it into 2 weeks? No, that's not possible, right? Even if you build a prototype in 2 weeks, you're going to have to rebuild it to be able to take into consideration of how you're going to scale it, right? That's called technical debt. So we have an ML code, which is a very small component of it. Besides this, to be able to productionalize, not for experimentation, but to be able to productionalize, you're going to have to go through your data verification, your analysis. What does your infrastructure look like? What does your serving infrastructure look like? How are you going to monitor the model? What are your process management tools? How are you going to automatically extract the features? Now, let's say we make a model, we have 1 month of data and we make the model, and 3 months later, the data changes. So that means that it wasn't like the machine learning model that we made isn't robust enough to be able to even capture that the data has changed. We'll just keep running the same model again and again. Right? So that is how companies are actually productionizing these days, which is why it's difficult to entirely trust machine learning, because we haven't done the work to be able to bring it to world class, right? So let's just elaborate a little bit more on what does the hidden technical debt in ML systems mean. Like it sounds fancy. This was a paper from Google, I think back in 2004. So here, the three main points that we can go through. Number one is complex models erode boundaries, which means if you want to work on any sort of problem with a team or with multiple teams, you can work on silos initially. But as you scale up, you're going to have to work with other teams to be able to have a complete product, right? Second thing is data dependencies cost way more than code dependencies, which means let's say you are trusting 3 data sets to be able to build one single machine learning model, right? From this machine learning model, this output is another machine learning model, right? So let's say over time, the customer has drifted, right? Like let's say people were buying clothes before and now they want to buy makeup, right? So with this model drift, are we able to update the model? Do we know when we should retrain? Right? And let's say we have some sort of product IDs, and from there, one of the product IDs gets archived or removed, right? That means you have to train the entire model again. So it's a very expensive thing to do because it follows the case principle, which is CACE. Change anything and it changes everything, right? So how are we going to take care? So like that's the issue when we scale up too fast, or when we're trying to scale, we are actually doing our homework, right? And something called ML systems anti-pattern, which is we pull in packages to do certain kinds of work, and all of us keep using different versions, different sort of things to be able to do that one task. But if something changes, or if somebody else is using something else, we use something called glue code, which is just to be able to stick the thing together. And this becomes difficult to maintain over a long period of time. Similarly, since it's called data science and not data engineering, science in the sense we have hypothesis, we try it out, some experiments work, a lot of experiments don't, right? So how are we managing and maintaining those older dead experiments? Can we use it later? Is there learning to be taken over? Now, does that mean that it's not at all possible to manage technical debt? No, it is. So how do you combat technical debt? We're still working on exactly how we can scale and combat technical debt at the same time. But here, there are 3 main points that are generally advised. Right? Number one is monitoring. Anytime you push any machine learning model into production, it's important to monitor how it's actually behaving in the real world and get user feedback or any sort of feedback to be able to see, okay, first month it ran well, second month it ran well, third month, okay, there's a drift. Am I able to get an alert for that? So what are the tools that we can use to be able to monitor a machine learning model in production? This is called MLOps, right? Next is data versioning and model metadata. Hey, I made this machine learning model on data I got 2 months ago. I'm looking at this now 2 years later, and the data has completely changed. Do you have a copy of the data that was there then? No, right? So similar, like if you folks have used GitHub, right? What does GitHub help us with? Git is a code versioning software, right? It handles the code. So similarly with data science, we also want to version the data. How has the data changed from the past? Because let's say a company like Tesla, right? Like let's say they're looking at making their models from 2 years ago. or maybe 1 year ago, right? The number of people that might have been there at that time because of pandemic must have been drastically less. And now, if the same models are applying, there are bound to be accidents. So how are we going to track that at that point, the data was biased towards having less people because of the pandemic, and now it's increased? This can be done through data versioning. And similarly, what models ran, what are the factors that come into play, what are the hyperparameters, how do we do hyperparameter tuning, how is our documentation happening? And we've been told as data scientists that, hey, documentation, 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 but it's not possible to document at this scale and keep building newer and keep trying to solve newer problems, right? So this can be done in an automated way through model versioning tools, right? Then you have other ML tools which are built for MLOps, which is built for scale, which is Weights and Biases is a company. You can look it up. We have MLflow and Kubeflow. So again, since MLOps is in the nascent stages, there are thousands of MLOps tools and everyone's fighting to get a chunk. You can imagine that this is the space in cloud before Google, Microsoft, or Azure came up, right? Everyone just has an idea that cloud is the future and everyone's trying the luck on what works, what doesn't. The two top contenders would be MLflow and Kubeflow. In an interview, in a discussion, if someone asks you, hey, what's a good MLOps tool, MLflow or Kubeflow, right? You can go ahead and even look at the documentation. It'll really help you understand what are the things they are considering. And is it really vague or can we make it a little more tangible, right? All right, so now if you look at new world machine learning, MLOps. What is MLOps? So MLOps is essentially used to optimize the handoff between data scientists and machine learning engineers, which means, okay, the model is done. How do I productionize it? How do we make that step easier? Right? So for that, what are the 3 goals that we have with MLOps? Number 1, we want to be able to focus our time not on maintaining data or documentation or going back and forth with 100 people. We want to focus our time on doing faster experimentation and model development. Next is whatever models we make, we want to be able to deploy that faster into production. And third thing we want to ensure is quality assurance, end to end, right? When we say take accountability, how do we come back and make sure that this is what happened in that particular phase, so this particular error is happening? How do we track that lineage of data, code, as well as the different models that we've run, right? Next, let's actually ask the question, right? Like the reason we're all here to understand, what is MLOps, right? So MLOps is essentially a process that encourages the data scientists and the engineering teams to collaborate, right? And we want to increase the pace of, again, modern model development, continuous integration, deployment, which is CI/CD, which is, okay, I am experimenting with a model. I've made the change. I want to see how it performs in the real world. How fast can I get there? Let's say, okay, 7 people have already worked on a model. Let's say we're trying to predict the price of cars real time on Cars 24. I want to come and update that model. I have gotten more data now. I have a higher quality of data. I have more number of customers. I have new features, and I want to implement and see how fast can we do that, right? So that can be done very efficiently through the help of CI/CD, which is continuous integration and deployment. And the third thing is proper monitoring, validation, and governance. Now, models are tracking lives, like tracking our lives end to end, right? If you speak about something, Google's able to hear you. Instagram knows what you're doing. Those ads are so relevant. So similarly, like these might seem like small things right now, but let's take another example, right? Amazon tracks the movements of its truck drivers. And if the model says that the truck driver is not doing well, they will either get a pay cut or they'll be fired without any human intervention. Now, is this fair? Is the model right? Does the model have a bias? Like how do we prove all of this, right? So this is where model governance and responsible AI comes into play, right? So all of this can be done through the power of MLOps, and this is what MLOps is aiming to get, right? So we have our design phase, we have a model deployment, and we want to go into our operations, right? So here we have our requirements engineering. Yeah, so like this is, I think, self-explanatory, but excuse me, sorry. Yeah. So we go from a design phase to model development to operations. These are 3 core components of MLOps, right? All right. So let's look at, why do we need MLOps? Like what do we achieve from MLOps? Like what are the additional things that we can get? Like, hey, Anish, I already work as a data scientist. I have data, I do experiments, and I make model. My clients are happy. What more can I get from MLOps or by trying to bring this about in my company or having a discussion with clients about this, right? So first few things, you can do much faster experimentation. You can track your metrics end to end, who did it, when it was done, what did my data, model, and life cycle look like. You can production much faster. Third thing is your data, model, and code. All of these three things, there's a tool like similar to GitHub, right? There's a tool called DVC, where we're able to track all of this, and it's just automated. So if you want, you can go back to what you did on 2nd February at 5 o'clock, anytime. Instead of relying on, hey, can you send me the Jupyter notebook over email? I'm not able to find it. Did you change the data? Okay, great. Can you tell me the name of the new data set? Can you correct the name of your notebook so I know where I can look for what you did 7 months ago? It's just not possible to be able to have those conversations with your teammates consistently, right? So it's better to have it in one common place. And that's what MLOps can do by bringing about checkpoints in the ML lifecycle. Okay, let's say we have some malicious intent. Somebody has been collecting the data to train cars, and they're changing everything by just a little bit. Now, when we're talking about something as serious as human lives, even a little bit can kill someone, right? So how do we make sure that we are responsibly doing it? Right? So all these things can be tracked. It gives accountability, sort of like how blockchain would give you like a decentralized approach. MLOps can give you a centralized, but it can tell you who did what at what stage and what were changes that were done. Next is, let's say we have a change, right? How do we do automatic validation? Somebody's pushed some new code, some new function, some new model attribute has come. What are the 20 tests that we do that we know that this model works? Now, let's say we know, okay, we'll do two tests, right? We'll see, okay, how many rows are there? Does this happen, that happen? But over mistakes, we know that, okay, there are 20 more checks that we can do to ensure that this is a good enough model for this use case. What does my bias look like? What does my variance look like? If I'm doing classification model, what are my metrics looking like? Right? So this can automatically be done through the help of pipelines. Right? So you can also monitor your model performance. It's a very common question in interviews these days. Like, okay, have you ever deployed a model? Okay, how did you track the model drift? What is model drift? What is concept drift? What is data drift? All of this can be analyzed through automated dashboards, where you just look at once every 3 months. Okay, all good. Any issues? Alert, email. Okay, look at the data, change something, experiment, see if you're able to get a sufficient model out of it, and then deploy. That should be the speed that we're working at. Next thing we're looking at is, okay, now let's say we have an error, we need to retrain. Can we automatically retrain it? Because we know that the data has changed a little bit, or there's a bias, or some sort of feature has changed. So how do we go about model observability? Right? Now, miscellaneous, there are also things like interpretability. Model is making a decision to fire an Amazon truck driver. Why? What are the 3 reasons? What are the 5 reasons? Can you show me those use cases? Are those validated? Did the sensor in the truck malfunction? All of this can be done through ML interpretability, or it's also called XAI, which is explainable AI. Next is fairness. Now some companies have their own laws. If you Google responsible AI or responsible ML, Google has their own code, Shopify has their own code, Amazon has their own code, right? But shouldn't it be standardized, like what we call fair, or should it be debated instead of having all empowering corporate decide, right? So how do we go about and do audits, right? MLOps can enable us to create audit trails, right? Now, let's move on to 5th topic, which is tools and technologies for MLOps. 2 more topics. I hope all of you are still engaged. I know it's a little heavy, but MLOps is a very, very interesting area coming up, and that's where the future jobs and demand in the market is, to be honest. Right? So now, tools and technologies. All right. So we have a huge set of tools and technologies where we're trying to focus on. I'll just zoom in so you guys can see better. All right. So we have data collection and labeling, data exploration, model training and evaluation, and model deployment. Some of these tools you might be familiar with, some might be new to you. Like, hey, I know Jupyter Notebook, I know GitHub, GitLab, Bitbucket. I know these packages, I've used it. Okay, what are the new things that we're going? Because still here, feature engineering, maybe even model training, we're still comfortable. Then deployment. Okay, you can build your POCs through something called streamlit.io. Model debugging, tracking, model packaging, workflow and orchestration. We talked about DVC, all these tools. And you're like, Anish, what are you trying to show me? There are a lot of ways to do the same thing, right? If you guys are cloud engineers, you know that the same task can be achieved by this like 3 or 4, maybe 5 different combination of tools. Similarly, at the moment, all of these are the competitors that are working towards building an MLOps end-to-end stack. Think about it as building like an ecosystem, right? Let's say Android versus iPhone. Why is iPhone considered more rounded off? Because everything is built by a single controller. But if they make a change, then everything has to change. So similarly, Amazon has AWS SageMaker, Google has Vertex.ai, which is a integrated MLOps platform. And we also have Azure that has ML Studio. So they will be the controlling figure for that. But there are also open source alternatives, which is what is shown here. If you guys are interested to talk about any more of these in detail, like any tool, because we can go about what the popular tools are, and I'll also showcase it. But in case in future webinars, if you want to see a hands-on on any one of these tools, we can do that as well. All right. So tools again, how do we perform MLOps? Like we've spoken about what is it, benefits, how to go about it, but like how do we perform it, right? So first thing is create reproducible pipelines where you focus on how do you automate as much of it as possible, not just the engineering aspects, but also the experimentation aspects. Let's say I'm trying to build 7 models. Should I have 7 different outputs every single time where I run the train code, predict code, fit code, and all of that? Or do I build one generalized pipeline where I give data set and I give a few inputs like as functions and the pipeline is able to run automatically. Right? That's a good way to start off with MLOps. Next is reusable ML environments. A lot of work in production is done using virtual environments, right? So similarly, you can create machine learning environments, or they're already being created for you. For instance, GitHub has GitHub code spaces where you can have a laptop that has 4 GB RAM, but use a code environment that has 64 GB, right? And tomorrow, if your laptop breaks, you get another laptop, log into your browser and start from the same place, right? That's where the future is going. Yeah, even in terms of automation, GitHub has come out with something called GitHub Actions, where, okay, you make a code change, it's going to go through 17 tests, and then it's going to deploy. It's going to happen instantly, right? You can go ahead and look at those videos. Next is register, package, and deploy your models, track them through model registry. Next is you capture your governance for end-to-end lifecycle. So now it's not just make a model and run it and see how it goes. A lot of countries, especially the European Union, have their GDPR laws where if you're dealing with PII, which is personally identifiable information, you need to be very, very compliant to the privacy laws of that particular region. So how are you building machine learning models? And how are you doing ML governance, machine learning governance, to ensure that everybody is following the same rules throughout the organization? What are the tests that you have in place to ensure that you're doing ethical AI within the pipeline and even in terms of the outputs that we're getting? Next is generate alerts, right? Like that's one thing that people are trying to work on. There are ways to do it. Like you can send 1 or 2 emails, but how do we make it a more streamlined, efficient system? These are the areas of research right now that are still ongoing. You can go to MLOps.community. It's a website where all this is explained about what are the latest updates going on in the MLOps community. Next, how do we monitor our ML applications? How do we automate the end-to-end ML lifecycle, which is all the way from getting data, understanding the lineage, model, lineage, output, and monitoring. That is the end-to-end lifecycle that MLOps is looking to automate. Next is how do we create an audit trail so that we have asset integrity and we match regulatory compliance. Now, we saw all those tools back in the last slide. So some of the more common tools, if you want to build a Avenger pack of MLOps to say, would be to orchestrate. People generally prefer Apache Airflow, which is an open source tool by Apache where you're able to automate your pipelines, your models, and your cluster requirements, anything, right? Even the top cloud platforms like GCP, AWS, and Azure use Apache Airflow internally for a lot of their orchestration. Next is DVC, which is the equivalent of GitHub right now. Next is your experiment management and model management, which is done by MLflow. We also talked about Kubeflow. And then we have our model monitoring, which is done through Ben2M. Right? These are some of the ones that I have seen being used in the industry. All right. So just one quick slide, I think, tools and technologies. This is what the competition looks like right now. You might ask, why are you showing us so many tools? Because again, it's in the nascent stages, right? It's being developed, it's being researched. Companies are out there trying to be the first one to get something so the industry follows suit, right? So all of these are the set of tools like Data Robot, Domino Data Labs, Iguazio, right? All of these are the MLOps tools that are trying to solve the problem of MLOps, right? End to end. And these are different components, right? This is a great slide. All right. So we're almost at the end. So we'll just have our key takeaways. You guys met me. Hi, it's been fun. So we learned more about the fundamentals of MLOps. Yeah, we have a solid understanding, and this was a very heavy, intense presentation. So feel free to go back and have a look at it again. Next is, how do you scale up your data science projects, whether you're doing it individually or you're trying to do it as a large group. Even individually, you can go ahead and do MLOps so that you understand how an individual implementation works. So you are the one that can scale it up later. One good example that I give is, if you're running away from a bear, you don't need to be the fastest person in the world. You need to be faster than the 10 other people behind you. So similarly, if 2 years later, somebody's asking for an MLOps engineer, you might know 50%. Maybe you just attend this webinar and you got an idea and you started off, right? You might be ahead of 90% of people appearing for that interview. So you'll get selected. And since there's a demand supply mismatch, you'll get paid more, right? So focus a lot on what is the market looking for right now. And MLOps is definitely one of them. The third thing, we understood more about the hidden technical debt in machine learning systems, the current and future state of machine learning. And finally, we also briefly went over the tools and technologies that we use in MLOps, right? Thank you so much for giving me about 45 minutes of your time. We can go on to the Q&A section, and Shir, like, you can go ahead. Thanks, guys.
Oh yeah, so I've started off the poll, so I would like you guys to participate, and then we will start off with the Q&A section.
Thank you so much for your attention. Like,
so there are total 3 questions I would like the attendees to kindly fill up.
yeah, and if you guys want to connect with me, again, you can Google my name, or you can connect with me on LinkedIn or email me directly. I'm always happy to help. I've mentored and helped over 2,000 plus people get into data science. So I will try my best. And if you want to have any other sort of discussions about like projects you're working on, what does ML observability look like in the future, I'm always game to learn more, because I'm also learning personally. So yeah.
Great. I think we can go ahead with the Q&A section now. Anish, there are a few good questions which we can take up.
Yeah, sure.
I think we can go ahead with the. I think you can see the questions also on your screen in the Q&A tab, and there are a few questions in the chat sections as well. So I would request attendees first of all to use just one, maybe the Q&A section, to pose in all the relevant questions you have for the session, and Anish will be happy to help you out.
All right, sure thing. I think the first question I will take is from Ravi Kumar BN. How does the fault of failure to predict, like, how is that handled by the model is the question, right? So this is a question I've been asked in an Amazon interview. Like, hey, you've deployed a model, and now let's say you deployed it and some change was made because of the model. So how are you going to handle that fault? There's not an accurate answer, but one way to go about it is what are the changes you can make in the training phase to be able to accommodate for that error? Can you overcome that error? Or second is, don't retrain your model unless absolutely necessary, and then maybe when it reaches like a complete fault stage, then you retrain the entire system. right? So it's not a perfect answer, but that's something that the industry is again working towards, because again, if the data has a fault or your model is biased towards one certain result, it's not very easy to come out of it unless you rebuild the system sometimes. So what are the acceptable ranges within which your business use case is still justified and you're able to make money from the model? Yeah. Okay. We'll take a question from anonymous attendee. In one sentence, what is MLOps? How do you define MLOps as a part of the whole model building procedure? Okay. In one sentence, MLOps is a combination of the machine learning and the engineering or operationalization phase. The MLOps part of it comes after the whole data science part of it, which is how do I actually push the model that we've made and make money from it? Because see, if you go on Kaggle and you do a problem, we're looking at, okay, let me apply linear regression and make a model. And let's say we're doing house price prediction, right, based on 10 factors. Now, if I can give you the price of houses every day for the last 20 years and give it to you every single day for the next 1 year, how good is your model in the real world, right? MLOps is bringing data science or machine learning into the real world where we're able to make money from it. I hope that answers your question, anonymous attendee. Okay. Next is, what is the tool used to version data? By Sakti Ramalingam. Hi, Sakti. So DVC is one of the tools. And I'll just go back to that slide. There's also Pachyderm that's used. So even in this slide, you can go ahead and see what the different ways we can track our data versioning. Right? All right. And this is done. Okay. Is it the fact that AI ethics? So Gopi G wants to ask, is AI ethics manager will be there in MLOps? So machine learning and data science teams are evolving now. So we are able to see that there are people who are representing that. Generally, I've seen folks with PhDs who understand what ethical AI is, right? Like, let's say somebody's tracking every single stroke on your phone. What do you like? What do you dislike? How many hours a day do you use Instagram, Facebook, or WhatsApp? And then getting all the data and leveraging it. Can we do that in an anonymous way? Right. So rather than trying to make it more person oriented, who's going to decide, which is a problem, right? Personalized bias, but trying to make it an anonymized system where we're able to leverage the power of machine learning to anonymize that and still make it ethical while making it follow a certain set of laws, right? So like process over people is the ideal world, right? Okay. Okay. So Sinchan S asked, what is the minimal tech stack required for MLOps? Okay, this is a tough one. So there are actually a lot of ways you can go about it, but from something that I've seen, for your data engineering, if you're able to get your data from AWS, GCP, or Azure, that's fine. If you're doing actual experimentation using Jupyter Notebooks, or you're using some sort of an API through AutoML, that will be the experimentation part of it. For deployment, you can do it through cron jobs, you can do it through Apache Airflow, right? So like those are the tools I've seen being used. Within that, there are more advanced or like other alternatives like Azure Data Factory to be able to orchestrate everything end to end. And from there, for deployment and model management, you can use MLflow or Kubeflow. And finally, for model monitoring, you can use Bent2ML. So that would be the minimal tech stack, something like what I showed you in that slide. Okay. In the slide on how to perform MLOps, this is by Giverges George. Would you elaborate on the point? Automate the end-to-end ML lifecycle. Yeah. So machine learning has a lot of small steps in between, like feature engineering, get the data, clean it, aggregate it, source it. So I might be able to do it right. That's the second person can do it right. But can the third person do it right? Should we be dependent on people for it? Or if two people are able to do it right, can we write generalized code so that anybody can just implement the code or run the code and they're able to automate the machine learning part of it, right? So yeah. So yeah, that's how you can automate the end-to-end ML lifecycle.
One of the question has been asked by Gayatri. So she says that, "Hey Anish, can you give a brief overview on how exactly future stores are useful in real time? Especially what exactly are we storing? Is it the feature transformation or the features themselves?"
Got it. Thanks, Gayatri. All right. Yeah. So Google's MLOps tools, right? Vertex AI has an example of this, where you have your features which you have, and from there you want to build, like let's say we have 500 features, and from there we run some sort of top n feature selection, and we have like like 50 features are important or 20 features. So that will become one set of features. So we're actually storing the names of the metadata of the features, right? If you've done some transformation and you got a new data, so that metadata and that transformation is stored, so that you'll be not just get the final result, but also what are the steps you need to do to get to that particular feature set, right? So it's again something that's in beta, but you could probably look up different implementations of it. It's fairly self-explanatory, but we store the features and not like what the formula was to get that feature, right? Yeah. What are the open source? So Vidhya Sagar is asking, what are the open source tools used for model monitoring? We have Bento ML. I think we've covered that. Aditya Bachu.
So yeah, one
Sorry,
of the
go ahead.
question is asked in the chat section. If you can read it, I think it's by Srikant Taniru. So he has a question with respect to ML infrastructure management or container orchestration aspect of MLOps. How is the knowledge gap handled by ML engineers when they have to enter into onto K8 space? So
Got it. Yeah, like see, which is why that's a really good question, Shrikant. So for this, I'll probably go back to the future of enterprise ML that we saw, right? Like this slide, because it's just not possible for one person to know everything end to end. Because before already, when we said data scientists, you should know everything end to end: engineering, visualization, experimentation, mathematics, business, technology. Nothing left. Now I'm saying automated also, which is know what DevOps is also doing, right? So it's not possible for one person to know everything, which is what is happening now because we're in the nascent stages. But ultimately, as teams evolve, as which is happening right now, we're looking at people who are an expert in, let's say, cloud or subject matter or product or data engineering, then machine learning engineering. Then you have one DevOps person, and a combination of all of this is going to lead to an efficient MLOps engineering team. Right? Thanks, Rekha. All right. So if you work, Arvind has a question, I'll try. If you work for an organization, choosing an MLOps platform is going to be done by people in executive position. So how do we prepare ourselves for that? Will different tools be different from company to company? Yeah. And not just that, even once a company or executive has selected a tool, if there's a management change or if they decide this doesn't work, there have been multiple times where you have to just stop building everything on one platform and move everything to another platform. See, like that's the cost of being at bleeding edge, right? Like all of us are trying and experimenting. So there's no right or wrong answer. So the best that you can do, like the logic that I use is, if you know your fundamentals, right? Which is a pie chart is a pie chart, whether you're building it on Power BI, Tableau, or on ClickSense, right? So focus on knowing the fundamental concepts, and the rest of it is wiggle room that will differ a little from tool to tool. Because the aim of MLOps is for it to be platform agnostic, and that is what everyone is working towards. Yeah. Okay. Jishi, is there any interesting question that you see?
yeah, I'm
Because
actually
I understand that we are at time, and I don't want
yeah.
to.
I think at max we can take up one or more two questions more.
Yeah.
Let me find it for you. So maybe we can take up a very basic question, because there were many people who are beginners into this field. So what would be a great place to start off if someone wants to get into this MLOps? So what would be the best way to start to go into this session, to go into this field of
Sorry,
MLOps?
could you repeat again?
So there were questions, I mean the basic questions, like, so what would be the best way to get into this field of MLOps, or how to start learning? What would be the best approach in that terms for the beginners?
Good. So MLOps is a little bit of an advanced topic. I'm not going to like that is my opinion. So a good way that I've seen is there are a bunch of great books on MLOps, practical MLOps. You have introduction to MLOps, and you also have the MLOps community. Right? There's a community on YouTube as well as yeah, there's a website. So if you're actually interested in understanding it, because this is still being built, so it's like following somebody like building something. So we don't know where we are going exactly. And if you want to be a leader in MLOps, right, even if it's not technology wise, but even knowledge wise, a good place to start is these books and these communities from where you can talk and hear the best of the best people. Because I have friends who entered MLOps, and right now they work with the people on Google who people in Google who wrote the paper. Right. So that's how fast you can grow, because there'll be a handful of people working on this, which is why there's such a high demand, and there will be a correspondingly very high pay for this as well. Yeah.
Great. I think
There's
we
this
are
comment
on.
by Shasha. So as a future recommendation, I appreciate this.
Yeah.
Please conduct a practical / hands-on session of MLOps in collaboration. Thank you, Shasha. He also said that he enjoyed the style of presentation and the lucid examples. Okay.
Yeah, definitely. I've taken this recommendation and will definitely look into it in the future. So yeah, I think we are on time, Anish. We'll end this session. So thanks a lot, first of all, for this wonderful session. I think I was personally hooked to the screen throughout whatever you're saying. So I'm sure our audience found it useful as well.
Perfect. Thank you so much, guys, for spending 1 hour with me. I hope I promised on the value that I said I would deliver.
Yeah. So this webinar, this session of DataHour ends here. So if you wish to conduct a webinar or are facing difficulty in registering, connect with us at editor@analyticsvidhya.com. We will be back with another session of the DataHour soon. The link is in the chat section. Till then, bye-bye and keep learning.
Thanks, guys.